Welcome back to the lecture series in bioenergy. Now, this brings us to two parameters, how they could be described, and their efficiency is tested based on, one is called, and this is what is most important for you, called compression ratio and the other one is called what is the amount of displacement. Okay. So, just to briefly talk to about the displacement, what we talk about, when you talk about a cylinder like this, okay. So, the displacement is basically in terms of the cylinder, the length, which is kind of, you can call it as the bore length of the cylinder, which is kind of the diameter of the cylinder, and the stroke length. And this is called the bore length. So, generally it is expressed in cubic centimeter. So, you multiply it with the number of cylinders what you are having in any kind of vehicle, you can calculate what is the displacement. Now, talking about the compression ratio, this is very important. So, say for example, if this is your size of the vessel, initially it filled like this much completely with the air fuel mixture. When you are compressing it, what is, how far you can compress it without it getting self ignited because of the thermal agitation. So, that decides what is the compression ratio, and this compression ratio is very, very important for you people to understand, because based on that we will be defining the features of the octane. So, this is one out of among the two what we talked about. This is spark ignition engine. This is the most simplistic way you can understand the spark ignition. Okay. Now, what about the compression ignition? Once we will finish the compression ignition, then we will talk about the octane number. Okay. So, now talking about the compression ignition, this is slightly different. So, compression ignition works in a different way. In compression ignition, what happens? You have again a cylinder like this, in which what you do, there is an intake of air, simple air. Okay. There is an air intake, and so the air fills. So, this is air has filled it up just like the way you saw it in the previous situation. Then the next step is, so once the air is filling, you are moving the piston down. So, here is your piston. Okay. Now, you are compressing the air back, second motion. So, in a very limited area, you are again pulling the piston back. So, what you are having is out here is compressed air, okay, which is step 2, compressing the air. And this compression of the air, because of the closeness of the molecule, they come so close, as I was trying to explain you in the spark ignition engines, they, because of the collision of these air molecules out there, they attain a very, very high temperature. The temperature of around approximately, they attain around 1400 degree Fahrenheit. This is the kind of temperature it rises, and at this stage what is being done, you inject, when the air temperature is so high, you inject the fuel into the system, and when you inject the fuel to such a system, what happens, because of so high temperature of the air, it leads to a immediate ignition and an explosion. Immediate ignition followed by an explosion. And this explosion, as you remember in the previous situation, leads to this piston now again follows the same thing. So, the piston now goes down automatically because of the explosion, because it pushes the piston down. So, this is the third time piston is making a motion. The next, all that exhaust as you did in previous one. So, this is the first situation when air filling, the first stroke, second stroke where you are compressing the air, third at this stage you are injecting the fuel. Because of the explosion, the the piston goes down. So, this is the third motion, first motion, second motion, which is going up, actually it is going up, and this is the third motion when it is again coming down. So, up, down. The fourth is where you are the exhaust is being thrown away. So, this is the fourth time a piston is making movement, but this time it is going upward as we did in the spark ignition. So, what you observe is in both of them the fundamental difference is this, that one uses air fuel mixture, the other one only uses the air and compress the air and use that compressed air for ignition. So, that brings us to the concept what we talk about, compression ignition engines. Now, having said this, now we will go back after having exposed you to these two different kind of engines. Now, we will go back to the concept of octane number. In the light of this information, your fundamentals will be clear what does the octane number means. So, octane number, the first information or first concept you have to get, octane number or octane rating is this, octane number or rating. So, the more compression the fuel can withstand before detonating. Okay. What does that mean? More compression the fuel can withstand before detonating. Okay. So, any fuel which could be compressed with respect to another fuel before it detonates is the octane number. So, going by the definition of the octane number, you can call it basically it is determined. So, let us see how it is being determined. Okay. It is determined by running the fuel in a test engine, by running the fuel in a test engine with various compression ratio. Now, you remember what is compression ratio. Compression ratio is basically, once again, so if you go back to the previous diagram, so amount of, okay, let me redo it for you. So, say for example, if this is the piston. So, this length, which is the length when it fills the whole cylinder versus upon compression when it goes up, this length, which is I am denoting by small l. So, the compression ratio is L versus a small l. So, higher you can compress a mixture without it getting self ignited makes you a much well controlled better fuel. Okay. So, it will have a higher octane number. So, let me finish this definition. So, with the various compression ratio under controlled conditions, okay, under controlled condition and comparing the results with those for mixtures of isooctane and N-heptane. Okay. So, these are also called, isooctane is also called a reference standard. So, in other words, what does that mean? So, whenever we are measuring a number, we give a value, say we talk about a pH or we talk about any other such values. So, we have to have a reference. So, in the case of octane number, the reference is being done with N-octane or sorry isooctane. So, isooctane is used for all the compression studies, and based on that, so with respect to isooctane, so I have this biofuel A, biofuel B or some other fuel, with respect to that how much is my ratio, how much I can compress it. If I assume this as 1, with respect to it how much I can compress. So, there is a scaling which is being done. Based on that scale, what you get here, now let me go back where I started. So, these are the numbers what you see, regular 87, plus 89, premium 92, high octane fuel 95. What does this signifies? This signifies that these different kind of fuel grades decides how much you can compress this particular oil or the fuel with respect to other. So, in other words, if you have a high octane fuel as shown out here, if you will see this one high octane fuel, it means you can take, suppose this is your cylinder, essentially you can compress it much more as compared to this one or as compared to this one, this will be more. So, in every case, so the compression, if I have to put the compression ratio, so that you will have a more compression here, more compression here, more compression here. How much you can compress, how much really you can bring it close in, how much you can pull the plunger back and shrink it, ensuring that it does not self ignite. That is very critical. We will come to that, what does that mean. And if you follow this picture, you have seen something. You see low octane rating, remember I told you, and high octane gasoline. It means when you are refining it with zeolites, the bio oils, and converting it using different kind of zeolites through the nanoreactor concepts what I told you, you actually can obtain very high octane fuel. That means, in other words, the flammability of those fuels will be much more higher and their efficiency will be much more higher as compared to the low octane rating. Okay. So, as compared to that, if you look here, so what you are having is the low octane rating out here. There is one high octane rating. So, these octane ratings are nothing but how much compression you can do. Okay. Now, to give you some idea about what are the different octane ratings. So, say for example, you have a high octane rating, high RON, whereas you have a low RON. Okay. Now, these things, this low octane rating will lead to something called a engine knocking. And what is engine knocking? Engine knocking is basically occurs when unburned fuel mixture auto ignites. So, this is a situation when unburned fuel slash air mixture auto ignites, which is in a way very dangerous, essentially leading to an explosion, essentially leading to an explosion in the engine. So, most of the low octane number fuels leads to the engine knocking problem. So, what happens because of certain degree of non-uniformity in the fuel molecules and certain of their physical properties, they, when you are compressing, leaving them, they self ignite. And you remember, people will remember that I was repeatedly telling they should not self ignite. If they do self ignite, then there will be issues. So, you want a fuel mixture to be compressed as much as you can, and then you spark or ignite it using a spark plug. Whereas, low octane number fuels like diesel, they have this problem, and these are being removed, and there are ways to get around it, and the engines are designed in such a way to handle those kind of knocking issues. Now, talking about few examples which I wanted to give you people about some of the octane ratings. So, if you talk about, so all of you have heard about hydrogen as a fuel, okay, and if you see what is the RON number or the octane number of hydrogen, it will be more than 130, okay. Just to give you an idea about different kind of octane ratings what you have. Then you have methane, which is 120. You have isopropanol, which is 118. You have propane, which is 112, and you have ethanol, which is 108. Now, having said this, that ethanol, it is very interesting, there are ethanol which are being mixed in the fuel. In the liquid fuel, you mix ethanol. Apparently, ethanol is a, if you see the number, so you see the number out here, 108. Now, check this number, what I showed you in the beginning. Check this number. You have a high octane fuel, 95. So, you have a 95 and you have ethanol. Now, let me add something here, okay. Ethanol, which is, say, you have 108. So, if you take a high octane fuel, mix it with partly with ethanol, what will happen? This number is going to go little up, and this is going to come little bit, but you are using a smaller amount of it, okay. So, this is going to go up. So, what you are attending is you are getting an high octane fuel. So, from an high octane fuel, you are increasing the octane number. So, you are increasing the efficiency of the fuel. So, there are many such additives which are being used, and one of the most common additive which is considered is that ethanol. So, there are several, ethanol, it is also is an octane booster, okay. I think it is clear to you people why it is called an octane booster, because it has a higher octane number, which is around 108 and you mix it with something which is 95, which is high octane fuel, you can actually certain percent, 10%, whatever percent you pick up. So, based on that you can really raise the octane value of it. So, octane rating of gasoline essentially tells how much of the air fuel mixture can be compressed before it will spontaneously ignite. So, let us put this definition is of octane rating OR, I am just putting OR for octane rating of gasoline essentially tells how much of the air fuel mixture can be compressed before it will spontaneously ignite. Why it will spontaneously ignite if you compress it far and beyond? Because the molecules will be so close and there will be so much collision between the molecules that will generate sufficient heat to reach its ignition temperature. Okay. So, if you now go back where we started in the beginning, we talked about by different route. If you do hydrogenation, you get low octane rating fuels like naphtha and diesel, which follows compression ignition systems. We have already talked about it. If you use zeolite and further refining and conversion, if you do, you get high octane gasoline and fuel oils, which uses spark ignition system. So, once this fundamental basics are clear to you, then whenever you buy a car, you exactly know, no one can fool you, or you go to a gas station, you know what is octane number and how that matters. Okay. So, these concepts are very important, and that is why I kind of bring it in a very simplistic note for you, so that you understand these, why you have to understand the basic engine design and where all these concepts, and there are so many modifications to this. If you pick up a go to Google or go to YouTube or any other good media, you will see very nice animations which are being shown, and I expect you guys read through them. So, one important thing, a take home message is, depending on the kind of treatment, depending on the kind of processing you do, you can change the physical properties of different biofuels, or you can change the fate of the biomass very significantly. As a matter of fact, the next lecture we will talk a little bit about pyrolysis, where you will see, as of now you have seen that we can convert by pyrolysis, we can, like, so we talked about when we are pyrolyzing it, we could make solid charcoals, we can make liquid bio oils, of course we can make fuel gas, which we haven't dealt as of now, we will talk about it later. So, among the solids, depending on what is the source or what kind of biomass, you can make very different kind of product. In the next class, what we will do, we will talk about one such product where using a natural fiber you can convert it into graphene like materials, which is one of the key material for energy storage. Okay. So, in the next class we will deal with that concept. Thank you.